Well, hi everybody. We're having a look at linear equations, and specifically today we're going to be looking at problem solving with linear equations, that is worded linear equations. So it's a little bit harder than just solving a linear equation that's given to you, because you've kind of got to make up the equation in the first place. Okay, worded questions. So here we go. We're solving problems with linear equations, okay? Yeah, and it's lots of fun. So, I'll see you over on the next page and we'll get going. Oh, here we are. Well, question 1. We're to write linear equations for each of the following statements using x to represent the unknown. Do not attempt to solve the equations. Okay, let's do A. When 7 is subtracted from a certain number, which we're going to call x, the result is 19. Okay? Now think about that. When 7 is subtracted from x, how do you write that? Yes, and we're using x as the question says, just to highlight that. X minus 7. Okay, and what does that equal? It equals 19. Hey, that's it, guys. So you just made up an equation from a worded statement. Okay, that's what we're doing today. What about B? 2 more than 5 times a certain number is 27, okay? Now, how do we do 2 more than 5 times a certain number? Well, we don't get ourselves confused, we break it down. How do we say 5 times a certain number? Yes, that's 5x. Then if we add 2 more, we get 5x plus 2, and that equals 27. Excellent, okay? We're on a roll, okay? What about C? Now, do you want to pause me and have a go and see if you can express that yourself? It's a little bit harder than the other two. Yes, when dividing a certain number, being x, by 3, the answer is 6 less than that same number. Goodness, I think we'll chunk this one down. Well, dividing a certain number by 3, I don't see that as a problem. That's x over 3, okay? But what does that equal to? The answer is 6 less than that same certain number. So it equals x minus 6, okay? Very good work. Okay, let's keep going. Question 2. Now, this is one we actually have to solve, okay, as are all the rest of the questions. If 4 is added to a certain number and the result is multiplied by 7, the answer is 56. Determine the original number, okay? Now, I'll give you a moment to think about that, okay? That's right. If 4 is added to a certain number, how do we write that? Well, first of all, we have to say, because they don't tell us what to call the number, so we have to tell them, okay? So you say, let the original number be x, okay? You really must say that, because otherwise we don't know what you're doing. Now, we can build on that. If 4 is added to a certain number, being x, okay? So I think that's how you do that. And then you multiply that whole thing by 7. I think that's how you do that, okay, the whole thing. So you've got to put it in a bracket, okay, the answer is 56. So I think that's how you do that. Now we've got our equation, we can solve it for x. It's just the same old stuff now. Let's multiply that nasty bracket out and see what we get. Now do you see how I did that? 7 times x plus 7 times 4. 7 is times to everything in the bracket. Yes? Now, which side do you want to have your x's on, and which side do you want to have your numbers on? That is your next decision. I think we'll have the x's on the left. Is that okay with you? Good. Let's do that. Now, then you ask yourself, well, what doesn't belong, which I have to get rid of? Okay? I think the 28. Yes, that's it. Let's do that from both sides. Okay? There it goes. Now we're going to clean up. Those cancelled out. That's what we were trying to do, those 28s on the left-hand side. Now we're going to do a clean-up line. Okay, a clean-up line. So therefore 7x equals, and of course 56 minus 28 is 28. Okay, now we've got to go again doing something. We've got the x term on its own. Now, it's times by 7, multiplied by 7. What is the opposite of multiplying by 7? Yes, it's divide by 7. So we're going to divide both sides by 7, okay? Here we go. Right, very good. Now let's do some cancelling. 7, yes, those 7s cancel out. 7 goes into 7, 1, and 7 into 7 on the top by 1. And then on the right-hand side, 7 goes into 28 4 times. So what are we left with, guys? After we do a clean-up line, we've got x equals 4. And I think that deserves a box. Great. That's our answer, okay? That's our answer. X is 4. And if you care to test that number out in the original equation, which we worked out above, you'll find that works just beautifully, okay? Proving that we're right. All right, feel like another one? Yes, of course, let's do it. Yes, and Mr. Thumbs Up, he's very happy because we're getting them right. Question 3. Okay, Laura is hiring a car from the AAA hire car company and she pays $45 a day plus $2 for every kilometre she travels. If she hires the car from Rent a Rocket, on the other hand, she pays $60 a day, which is more per day, but she pays less, $1.50 instead of $2 per kilometre. Okay, that's the idea. Now, Laura's got to work out which is the best way to go here, guys, and we are going to help her. So Laura needs to hire a car for 4 days while she's on holidays. So what is that? What have we got to do? Part A says, how far can she travel so that the cost of hire from either company becomes the same? All right, well, we better define some terms here, guys. They don't give us any symbols, no pronumerals in sight anywhere. That's the very first thing we have to do, okay? All right, I'll say, let's see, capital C be the cost of car hire. And seeing we're considering 2 different companies, probably I can have CA from AAA and CR from Rent a Rocket. Does that make sense to you? I think so. And we've also got to have some way of identifying in an equation the kilometres that she travels, right? So let K, that makes sense to me, be the number of kilometres travelled. Fair enough? Now we can set about doing our equation. So we're saying that in part A, we know that CA, the cost from the first company, AAA, is equal to the cost from the second company. It should be CR. Sorry about that. CR. Could you just imagine an R there instead of the B? Good. Therefore, we're saying that the cost from AAA is 45 times 4. That's $45 a day times 4 days plus $2 for every kilometre. So that would be $2 times the kilometres that she travels. Yes? Now that's the cost from A. But that equals the cost from Rent a Rocket, which would be $60 times 4 plus $1.50. Now $1.50 is $1.50. $1.50 is 3 halves, or 3 over 2. Okay, 3 halves times the number of kilometres travelled. Now we're going to work out what K is, because that's what they asked us. How far? Okay, the costs are equal. Now it's up to us to solve it for the kilometres as asked. Okay, no problem from here on in, guys. We've got it all set up. We just have to crunch our way through the algebra and the answer is ours. Simplifying a little bit, I've got 180 plus 2k on the left-hand side equals 240 plus 1.5k on the right-hand side. Now, which side do you want your k's? Which side do you want your numbers? I think we'll go for the left-hand side for the k's, if that's all right with you, and we'll go for the right-hand side for the numbers. So, therefore, what's out of place? What do we need to get rid of? Remembering, we have to play the game of opposites and keep everything balanced. I think we'll get rid of the 180 from the left-hand side, so we'll subtract it from both sides, okay, because it's out of place. It's a number which is on the k side of the equation, right? Let's do that. Now, we get 180 minus 180 plus 2k equals 240 minus 180 plus 3 over 2k. Clean up, guys. That goes. That's what we were trying to do, okay? Now let's do a clean up line. Therefore, 2k is equal to, and of course 240 minus 180 is 60, plus 3 over 2k. Good, now we're ready to go again. What should we do? Where do we want the k's? Yes, on the left. So there's a k term on the right. We don't want it there, so we're going to do the game of opposites. Yeah, let's do that. Subtract that from both sides, and here we go. We've got 2k minus 3 over 2k equals 60 plus 3 over 2k minus 3 over 2k. We've done it to both sides. Let's clean up now. Good. They go because they cancel out. Now I think we better go over the page. We're running out of room here. Okay, so that's where we got to. Okay, now what are we going to do? We're just going to simplify the left-hand side. But to do that, guys, we've got a fraction there. We've got a 2k, which is a whole number 2 over 1, in other words, minus 3 over 2. We cannot add them unless we make the denominators the same, okay? So let's give that a go. I've got 2 over 1, and I'm multiplying the top and the bottom by 2, so I can have a denominator of 2, okay? Because the denominator in the 3 over 2 is 2. Now, let's simplify again. We've got 4 over 2k minus 3 over 2k. Now we can deal with those numerators, now that the denominators are the same. Therefore, we've got a half k equals, okay, 4 over 2 minus 3 over 2 is 1 over 2. K equals 60, and what do we need to do now to get just k? It's divided by 2, therefore we need to multiply both sides by 2. Okay? And see how we go. Therefore, we get yes. Does that look right? I think so. Now we're going to clean up the left by cancelling, and we get k equals 120 kilometres, and I think that deserves a box. That is the distance that Laura would travel such that the cost of both of those companies would be the same. It wouldn't matter. It wouldn't matter which one she hired from. She would still pay the same amount. Okay? Good. Now we've got to do B. If she travelled 200 kilometres but over 3 days, not 4 days, which company would be cheaper and by how much? Okay? Right. Number B for you and me. What you would get is the cost from AAA would be $45 a day times 3 days plus 200 kilometres at $2 for every kilometre, okay? So what does that come to? A lot of money, I think. That's 135 plus 400, which gets you $535. Good heavens, I hope she really needs that car. Now, what about the CB? I mean CR, guys, the Rent-A-Rocket. Now, all right, so that's more per day but less per kilometre. Let's see how it works out. $60 a day times 3 days plus $1.50 times 200 kilometres. Now, what does that come to? Okay, we've got some cancelling. The 2 on the denominator goes into the 200 on the numerator, and we get that goes into it 100 times. So how does that cancel out and come out? It's 180 plus 300, which comes to 480. Goodness me, now just look at that. See, the Rent-A-Rocket company is cheaper than the AAA company, even though it was dearer to hire per day. It just depends on how many kilometres you're going to do. Isn't that interesting? So therefore, we've got Rent-A-Rocket is cheaper by $55. Good grief. How do you like that? So do your sums, guys, if you're going on holidays. Thanks, Mr. Box. Yeah. So there you go. There's that question. A nice worded question for you. Hope Laura's happy with us. Right, next one. We've got here a classroom contained equal numbers of boys and girls. 6 boys left the room to have vaccinations, poor fellas, and 1 girl left the room for an appointment with the doctor. Poor girl must have been sick. This left exactly twice as many girls in the room as there were boys. What was the original number of girls and boys in the classroom? Well, now, guys, look, there's no pronumerals anywhere in sight. If you want to have a go at it, pause me and then come back and you can see how you went, okay? Right. Now, we have to define a term here because they haven't given us any terms. That's the very first thing you have to do. Now, what I normally do with this, guys, is I look at what they're asking me for. That's usually in the last sentence. There it is. And that's usually what I define as my pronumeral or my unknown. And that's what I'm going to do in this case, guys. And I recommend that to you. Okay? So let X equal the original number of girls in the classroom. Yes? And of course, if there's X girls, the first sentence said that there's equal numbers of boys and girls. So therefore, we've got to have X boys in the classroom also. Okay? Now we've got to fiddle with the other information they give us to make an equation which we can solve for X. Okay? So look, just chunk it down bit by bit. Okay? How many boys left, guys? Read the question. Yeah, there were 6. So all right, so if you have 6 boys, I mean X boys, and 6 of them leave, how many do you have remaining in the class? Yes, okay, yes, that's right. You have X minus 6 boys present. Now, come on, I want you to do the same thing with the girls, right? After the one girl left to go to the doctor, how many girls have we got left? Yes, we've got X minus 1 girls present, okay? Now, what is the next sentence telling us? This left, I'll show you. There it is in green. This left exactly twice as many girls in the room as there were boys. Now, you've got to put that into an equation, okay? Right? How many girls have we got? X minus 1. How many boys have we got? X minus 6. So we're saying that the X minus 1 is twice the X minus 6, aren't we? I think we are. So let's write that down. We're saying that X minus 1 is twice X minus 6. Da-da-da-da! We've got our equation. Okay? Let's solve it for X, and then the answer is ours for the taking. Okay, so X, I've multiplied that nasty little bracket out. Okay, do you agree with me? 2 times X, and then there's plus 2, it's a plus, that 2, times minus 6. The signs are different, so it's minus, and 2 times 6 is 12. Okay? Now, which side do you want your X's, guys? Which side do you want your numbers? I think we'll go with the X's on the other side, the right-hand side, okay? Doesn't really matter. You'll still get the end result the same, but I just think that's a bit more convenient. Otherwise, I'm going to end up with minus X's, and I don't feel like having minus X's, okay? And we'll do the numbers on the other side. Is that all right with you? Good. Now we've got to work out what's out of place. And what are we going to do with the game of opposites to get rid of things which where we don't want them, where they don't belong? Okay, so what I think we could do is we could add 12 to both sides, because that 12 is a number on the X side. Yes, the game of opposites says we have to plus it because it's a minus 12. Okay, so there I did it. Okay, I've done it. Now we clean up. Okay, and then we write up clean up line. Okay, so the left hand side is going to become, look at the tug of war between the 12 people on the plus team and the 1 person on the negative team. So which team wins and by how many? Yes, that's right. X plus 11 equals 2x. Good. Now, what doesn't belong now? Remember, which side is the X side? The right-hand side. So that X on the left doesn't belong. So why don't we just subtract him from both sides? Good work. And let's do that. There it is. That's the left-hand side, and here's the right-hand side, okay? There it is. Now we've got to clean up. Good. And the right-hand side is going to become what? You tell me. Yes, just X. Okay, there's 2 of them minus 1 of them. So we get that, and I think that's our answer, guys. That is the answer. That is the number of girls and the number of boys who were originally in class. Okay, Mr. Box? Thank you, Mr. Box. Okay, how do you like it? Isn't it great? I mean, it's not really that hard, but it is a bit harder than just solving a linear equation, trying to get your equation set up and then solving it, yeah? Good work. Now we've got our friend Gary. He's trying to get fit, and he has started to jog to achieve this. Hope he doesn't ruin his knees. So, in week 1, he jogged a certain distance. In week 2, he jogged twice as far as he did in week 1. In week 3, he jogged 2 more kilometres than he did in week 2. Goodness. In week 4, he jogged twice as much as he did in week 2. And this is like a riddle, isn't it? And in week 5, he jogged 2 kilometres less than twice the distance he jogged in week 3. What a mouthful. Don't worry, guys, we'll sort it out. The total distance Gary jogged over the 5 weeks was 30 kilometres. Okay? Find how much Gary jogged each week, right? Now look, there's no pronumerals anywhere, but you always look at what they ask you, okay? That's what they asked. Okay, that's what you define, or what I always define my pronumeral or my unknown as, right? Now, I think I'll just go with the first week, okay, because every other week he did more than the first week, so that might be convenient. What if we call it X? What do you think? Good. X is the kilometres Gary jogged in week 1. Now, you have a look now. What's the next sentence about week 2? I'll underline it for you. There it is. In week 2, he jogged twice as far as he did in week 1, right? Now, what does that mean? How many kilometres is that compared to what we've got as X for week 1? Twice as much means, yes, it's 2X. Okay, that's week 2. Now, okay, I'm going to underline the week 3 sentence now for you. Okay, in week 3, he jogged 2 more kilometres than he did in week 2. Now, come on, what does that mean? We've done 2x in week 2, so what did he do in week 3? Yes, he did 2x plus 2 in week 3, alright? So far, so good. Now, here's the funny one here. Oh, no, week 4's alright, I'll just underline it for you. In week 4, he jogged twice as much as he did in week 2. Twice as much as week 2. Now, come on, what did he do in week 2? Yes, 2x. So what is twice as much as 2x? Yes, he did 4x in week 4. Look, this is really easy now, isn't it? It's really easy. So, now this one here's a bit of a killer. In week 5, he jogged 2 kilometres less than twice the distance he jogged in week 3. Well, look, what did he do in week 3? He did 2x plus 2, didn't he? Well, we've got to look at it again. Twice the distance and then take 2, I think. Yes, that's right, isn't it? Yes. Okay, so there's the sentence. Now, there's twice the distance, right? Because he did 2x plus 2 in week 2. Twice the distance means just double it, put a 2 outside the bracket and times it, right? Now we've got to subtract 2 from that because it's 2 kilometres less than twice the week 2 distance, yeah? There it is, okay? Now that wasn't so hard, really. Okay, that's week 5. Now, we've got all our ducks in a row here, guys, and now we've just got to add them all up and make them equal to how many kilometres? Yes, 30. That's week 1. There's week 2. There's week 3. There's week 4. And there's week 5. And what does it equal? 30. Beautiful. Now we've got to solve it for x. I'm multiplying that bracket out for you. Now, look, it's going to be easy now for us to work this out, okay? I think I have to go over the page, though. Yes, okay? And that's where we got to, all right? Now, be careful. How many x's have we got there? They're everywhere. So let's just work them out. There's 1x, add 2x is 3x, add 2x is 5x, add 4x is 9x, and add another 4 is 13x, isn't it? Good, 13x. Now let's do the numbers. I think 2 of those numbers cancel out. Yes, those 2's, yeah, that's nice and convenient, isn't it? And now the only one left now is the 4, so we'll put that 4, 13x plus 4, and that's equal to 30. Now we've got our equation. Oh, thank goodness for that. Now what would you like to do? I think we'll leave the x's on the left, the numbers on the right. So there's a number on the left which doesn't belong. It's number plus 4. So we do the game of opposites, and we subtract 4. Yeah? Good. There it comes. Good, good, good. And we cancel out, and then we clean up. So 13x will be 26. Now, we've got 13 times x equals 26. We're going to divide both sides by 13. By 13, not 2, sorry about that. And that will get us blah, 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 da-da-da-da, and that gets us that. And we get x is 2. Oh, I must have had 2 on the brain. Sorry, guys. So we're just going to we're going to work out every single week what he travelled, okay? And we'll see what we come up with. Right, how far did Gary jog each week? So, week 1, he did x, didn't he? And x is 2. Yes, good. Week 2, he did, well, I'll just tell you, you would have to look over the page, but he did 2x in week 2, which is 2 times 2, isn't it? 4 kilometres. Now, in week 3, Gary jogged 2x plus 2. Now, if x is 2, that's 2 times 2, that's 4, plus 2 gets us 6. Good work. Now, week 4, we worked out over the page that he did 4x. Okay, if x is 2, 4x is 8. You get the pattern, don't you? 2, 4, 6, 8. Guess what week 5 is going to be? I think you know. I ran out of room, so I'm doing it up here for you. So week 5, he's going to do this funny thing. Now, if you put 2 for x, then inside the bracket you'll get 2 2s are 4, that's the 2x, plus 2 gets you 6. Now, that's what's inside the bracket, the 6, times that by the 2, outside the bracket, 2 6s are 12, 12 take 2 is 10. Okay, there you go, guys, we've solved the problem. Gary's getting very fit, isn't he? So therefore there's week 1, week 2, week 3, week 4, week 5, okay? And you're a star. Yes, you are. Now, that's the end of our problems, but I want to go back to the original question and see if you can solve those equations that we set up. Wait a minute. Stop that. Mr. Computer is running away with the show. Now, I want you to see if you can solve those 3 equations, okay? Just for a little bit of extra practice. So, pause the video, solve them for me, and then restart the video and see if you get them right, okay? See you in a minute. Right, how did you go? I'll tell you the answers. This one was 26, this one was 5, and this one was 9. How did you go? Yes, of course you went really well. Congratulations and thanks for being a part of this little session, and we look forward to seeing you next time. Okay? Bye for now. Bye.